Welcome to this tutorial of the Kratos application. This is the fourth tutorial of the series, and in this one we are going to see how to set up a fluid dynamics simulation using the ROM application. In order to follow this tutorial, you will need to have installed GID, in this case the program type of Kratos, since we are setting it up from the beginning. And from Kratos Multiphysics you will need two applications, the fluid dynamics application and the ROM application. This is the example that we are going to be studying in this tutorial, and you can follow this link to go to the Kratos repository where we explain a little bit of the flow past a cylinder. This is the example that we're going to be solving, and the parameter, it is a single parameter, and we're going to be changing the viscosity, which in turn will modify the Reynolds number for this classical example. So what we will do is we will solve first just the time dependent problem, that is solve one instance that is the same viscosity, and we will get a matrix since this is a time dependent problem, and we will solve it using the raw manager, and then we will vary the viscosity by changing the materials.json. That's it. Let us go to OpenGID. Here we need to go to data, problem type, and Kratos, and here let us go to fluid and select the 2D example. There are some examples that are already set up here. If you go to examples window, you will see these are the examples that are already set up for the fluids application, and here you will see fluid cylinder in flow 2D. That's the one we are going to be solving. All of the parameters are already settled, like in particular, where is the viscosity? So dynamic viscosity, this is the one that is by default. This is, let's say, our mu 0, the original one that we're going to be solving first. Let us save this as fluid and mesh it. All of the parameters are already correct, so the mesh has been generated, and let us go to write calculation files, now run. And that's pretty much it. Yes, from GID we created this fluid.gid, and here, as before, we have the two project parameters, the Python file and the MDPA. We copy those on another folder that is called ROM2. Let us paste it here, and if we just do Python 3 main Kratos.py, you will see that the problem starts solving. I think the end time here was, let's open the project parameters, it's 45 seconds. Let us put on the, for the sake of this example, let us put only 5 seconds. Let's go for 10. So let us do Python 3 main Kratos.py, and as you see, it's solving, and it's creating the VTK and the GID outputs. Let's paste it here, and that's it. So that's the solution for this dynamic viscosity that is already contained in the materials.json. So if we open these fluid materials, you will see that here it indeed specifies the dynamic viscosity and the density, which for this case it's just 1. Let's now use as starting point the modifications that we did for the main Kratos.py in the structural example. As you will see here, this is a very similar main Kratos.py as the one used for the structure. So we have some auxiliary libraries, then the Kratos library, then this function which specifies a particular instance of the simulation that does some flushing. Then all of these lines set up the simulation object, and then this calls the run method in the simulation. So as before, we can simply comment everything. No, sorry, erased everything. And if we go to the first example, main Kratos, let us copy. Actually, let's copy everything from here and just paste it here and see how it should be changed. So the first thing that should be changed is here in the default parameters that we covered in the last tutorial. Let us erase the test stages for now, and let us also erase, why not, the false, the outputs, both of the outputs. The first thing that is very different is this one. Model part name is the fluid model part, and in nodal unknowns for this example we should put here velocity x, then so velocity y, oops, it's capitals, and pressure. So these are the unknowns for this particular example: velocity x, velocity y, and pressure. That's the model part name for the fluid. And we're not going to use this update project parameters function. So as we said before, we are going to use the viscosity already contained. So this should do, this update project parameters. We're not changing it, and we are not passing any mu. So basically we're saying use the one that is there by default. Manager.print errors. So these that we have here should already be equivalent to doing this. Basically launching the form for, in this case, for 10 seconds, as we said in the project parameters, then optimizing the snapshots matrix, and then launching the reduce of the model, and then since we put print errors, we are also validating the results. And of course we could probably well, let us see how it does for now. Let me erase everything. Oops, I am in the wrong folder. This is the one. So I just do, I can do it from the terminal, I can do it from here, so let us do it directly here. I just launch the debugger, and it should work. So it launches the fluid dynamic simulation the first 10 seconds, and then inside the raw manager it goes and does some optimization, and you can see it's a little bit faster. That's it. The error, it's of the order of 0.1%. 0.1%. So it's not as in the last case, which was of the order of 1 e to the minus 11, but then it is now 0.1%. That's the error using the full order model versus the reduced order model, and this is taking into account a single value of the viscosity. Let us now, as we did before, select mu train as a list of lists, in this case a single value on each of the lists, and let us put here let's go to GitHub hub Kratos Multiphysics, Kratos, applications, RAM application, Python scripts, ROM manager, and here the function that we need to provide is this update materials file. Let me just see the default implementation, which is over here. So I will just copy the default implementation and paste it here. By default, by the way, it's not calling anything. And so you saw the default was this, which is only passing. Let me name it as update project parameters file, and it does not pass. Uncomment this. So this will indeed read not a project parameters file. Actually, it is reading a string. It is creating a JSON and it will save it to disk. This is the way of modifying the material. So each simulation will go and load its own materials file. Therefore, if we want to change the materials, we need to save another one basically of these fluid materials. Let's put it here on a side. Do this here. So what we are going to do is we need to update this value of the dynamic viscosity. So by the way, this self shouldn't go there. Materials file name, by the way, this is going to be fluid materials.json. That's the name of this materials file, and mu, well, just put mu like that. In this case, mu is supposed to be, by the way, mu should be I don't know, hopefully this will do. So this should be good. We need to import the JSON library, of course. Import JSON, and then we need to go to data, properties, so properties has two. Properties 0 doesn't work for us right now. Properties 1, basically we're in this property, and then we go to material. Yes, that's the field that we want to change. Material, and then variables, and then dynamic viscosity, and that's this value. Well, that's whatever value we put in mu 0, by the way. And then it just stores it again. So this is a function that we should input to the ROM manager as a keyword argument like that. And let us just do some values around this. 0.4, let's say 0.7, and how about 0.1? And we do mu-train of this. Oops. That should do. So we have created a function, and we took this. We started this function by copying the default value in the ROM parameter in the ROM manager from the Kratos repository, and let's see if this works. So let us just try it. So it goes, it's complaining on this. Float object does not support item assignment. Float object does not support item assignment. Let me just see quickly what's the problem here. I had not been changing this. What is this? Yes. What is this? Oh, that's a dynamic viscosity, not dynamic viscosity here. So that should work. Yes, indeed. This is the idea. We just store a new fluid materials.json, and we can see that this should be modified on every iteration. 9 should be created every time it runs. Now the error form versus ROM is 6.6 e to the minus 5. Let's try and run it again. Yeah, man, it is just this. Let us try and do something now. We have created let's see. We have modified the materials parameters.json. We have created, not this case, but a similar case to the last tutorial. So basically this case, in which we passed 3 new train, and then we launched it, and when comparing the fit method, it gave us 1 e to the minus 5. We can do something now. We can launch a reducer model for longer, and maybe that is what it was interesting of this case. Let us comment out of that. Oops. Where is it? Let us comment out of this. And ROM manager dot ROM, and let us put here a list with a single list of 0.001, let's say. So this will run the reducer model, and maybe if I just change here, there is no field to change this directly from the ROM manager. Let us just put here 50, and this we hope this is a lot faster than running a full auto model. As you can see, the simulation goes quite fast. Well, not much faster, because for this particular example, there's not a great gain in speed, at least not only with this first stage of reduction. But as you see it's 50, so it already completed the 50 steps. Let us just, for comparison, run the form. That's it. You can notice that it is slower. And maybe that's why it would be interesting to create such a reducer model. We could have done this even with the unique parameter, as we explained before. So coming here and doing this with a single parameter would already work, because this is not a vector but a matrix, and with that we have captured the behavior during the first couple of seconds or minutes that we're simulating, and we can evolve the dynamics of the problem. So in this tutorial we have seen how to modify the JSON materials, basically reading a JSON file. In this case, this is not a Kratos parameters file, this is a JSON file. We change whatever we need to change using using this structure, a similar one, and we save it. Each of the Kratos simulations will go and load this particular file with the changed value in the material property, in this case using this syntax. Actually, we can go and check that it's changed correctly here, for example, and it says, you can notice that it indeed went and changed this value for us. So by doing that and passing this as a keyword argument that is expected by the run manager, we can change this value. In the following tutorials, we will see the rest of the parameters contained in the run manager, and some other uses of personalization. In particular, the one regarding in the previous tutorial, we used this one, how to modify or do changes in a particular simulation instance during the usage of the run manager.